Hello everybody and welcome to my video. My name is Norman LeMay and I am your statistical instructor. In this video I would like to take a look at possible errors that could be committed when performing a hypothesis test. So let's just note that in the decision making process, one of two things is going to happen. We'll either reject a null hypothesis or we will fail to reject a null hypothesis. So how do we know if one of those two decisions is the correct decision that we've made and we have not accidentally pulled a Britney Spears and oops, I did it again and made an error? So without further ado, let's get started. Cue the music. Hello and welcome. As previously stated, with decision making, we can make a correct decision or there can be an error, and an incorrect error may happen. I don't know if there's any other kind of an error. Incorrect error. I don't know. Anyways, this is probably one of them bloopers that should be cut out, but I'm not going to cut it out. So let's take a look at the decisions that we can make regarding hypothesis testing. There's only 4 options, so let's go ahead and jump into these in detail. Before getting to the 4 outcomes that we could take a look at, let's just note that with hypothesis testing, we will make one of the following 2 decisions. The first one is that we will fail to reject the null hypothesis. The second is that we will reject the null hypothesis. These are the 2 major outcomes of hypothesis testing that can happen. This does not mean that we have proved the null hypothesis or shown the null hypothesis is correct, because we've already assumed the null hypothesis. It's kind of the status quo. That is, what's the current situation. So, for example, if we take a look at the average annual salary of registered nurses, suppose that 5 years ago the average annual salary was $50,000 and an investigator or a researcher is interested if the average annual salaries has increased. All right, so here we have to start somewhere. So we just kind of assume that the null is true. That is, yeah, the average annual salary of registered nurses is $50,000. To reject the null hypothesis means that there is evidence in the data to support the alternative hypothesis. So if we come back and we survey, say, 30 registered nurses and their average annual salary is $55,000, then that $5,000 difference, there's enough evidence in the data to say the current status of $50,000 is incorrect and the $55,000 is correct. So we will reject the null in favor of the alternative. All right, so when we do this, the question is, did we make a correct decision? And that is what we want to investigate. So if we reject or fail to reject the null hypothesis, is there a way to determine if a correct or an incorrect decision has been made? To answer these questions, let's consider the viewpoint from the court system. So hopefully that we're all kind of familiar with the court systems, not because we've been to criminal court, but because we've seen enough of it on the telly. Or, you've seen enough Law and Order, or you've read enough John Grisham novels. So let's investigate. The null hypothesis is that the defendant is not guilty. We do not say innocent. This is a topic for another story. The alternative is that the defendant is guilty. In the American judicial system, the defendant is presumed not guilty. After the attorneys present their sides, the juries go and deliberate. Let's take a look at a first scenario. Suppose that Dudley Do Right is accused of murder. The bloody knife was found in his hands and the victim's blood was on his clothes. But the defendant was away in Paris, France, and it was determined that the body had been dead for 3 days. The jury comes back and the defendant is declared not guilty. Good decision. Everyone is happy. Now suppose that the jury is deliberating Ding Dong Drunky. Now this guy goes out and is found and has been accused of 6 DUIs in the past and has been let go. Driver's license never taken away. If it was taken away, it was given back. And this guy has probably gotten drunk and drove his car many other times. This particular night, he got so drunk he staggered out to his car, got into his car, was driving home, and runs into the rear end of a car sitting at a stoplight, killing an innocent 25-year-old woman. The jury goes and deliberates, and Ding Dong Drunky is found guilty, and a good decision has been made. Well, let's go back and reevaluate another scenario with Dudley Do-Right. But this time, let's suppose that the jury comes back and says guilty. All right. This time, the jury moves from the null hypothesis to the alternative hypothesis. Note that Dudley is wrongly accused of a crime that he was not even in country to commit. Since the jury moved from the null to the alternative erroneously, this is referred to as a type 1 error. And finally, let's go back to Ding Dong Drunky. But this time, let's suppose that the jury erroneously comes back and says not guilty. Since they chose not to convict a guilty person, they stayed at the null hypothesis and did not move to the alternative hypothesis. And this is referred to as a type 2 error. Remember, decision making under uncertainty, errors can be committed. We are not absolutely certain if an error is committed or not, but we can discuss the probability of committing an error. So let's take a look. If we reject the null hypothesis when the null hypothesis is true, then we have committed that type 1 error. So let's let alpha denote the probability of committing a type 1 error. Thus, alpha is the probability that you reject the null given that the alternative is false. In like manner, let's just denote the probability of committing a type 2 error by the Greek letter beta. So beta is the probability of committing the type 2 error, and another way of looking at this is that beta is the probability of failing to reject the null hypothesis given that the alternative is true. In conclusion, we need to keep the following in mind. First, when rejecting the null hypothesis, all right, we could be committing that type 1 error. So again, when you reject the null in favor of the alternative, then the idea that you have to question yourself, could I be committing a type 1 error? And there is a way to kind of investigate this and to get a little bit of confidence or comfortableness, if that's even a word, whether you have or may be committing that type 1 error. Second, when failing to reject the null hypothesis, that you could be committing that type 2 error. So again, when you fail to reject, just keep in mind that you have to question, could I be committing a type 2 error? So when you go out and you begin your research on a particular study, one of the things that has to be done first is that an alpha level has to be chosen. So keep in mind when it comes to performing the hypothesis test, again, we start off at that null hypothesis under the assumption about those mean, about that proportion, about the difference in the two means, and so forth. And if that error is to be committed, I hope that it makes sense that we would like to have that probability to be small. So some popular alpha levels are 0.1, 0.05, and 0.01. The 0.1 level is a 10% chance of committing that type 1 error, and the 0.05 is a 5% chance of committing the type 1 error, and the 0.01, which is the smallest, says that there is a 1% chance. So the question is, how much strength do you want to help you to not commit that type 1 error. So how much strength in the data do you want so that you're not committing that type 1 error? And let's just note that the 10%, the 5%, and 1% are just common alpha levels that are chosen. Technically, they don't have to be those levels, but these are the status quo, if you will. So let's just also note one other thing about alpha and beta, those two probabilities, is that when your alpha probability is high, say 0.1, then your beta probability is small. So if you need less evidence in the data of committing the type 1 error, then your probability, your beta, is pretty strong that you're not committing, and vice versa. These two will flip-flop. So if you decrease those chances, that probability, and make it small that you're committing the type 1 error, then your beta becomes higher. Now, there's that inverse relationship, but we are not going to get into how do you know which one is it. Trust me, it's a topic for a more advanced statistics course, and there is ways of talking about this and performing those. So I just wanted to bring this to your attention. So I hope this video has helped you out to understand the two types of error that can occur. And I would like to throw out one extra thing, and that is, between these two errors, the alpha error is considered the worst that can be committed. I should say the type 1 error is the worst error of the two that can be committed. Again, going back to our court system, let's just note that when the type 1 error is occurred, let's just recall that we start that the defendant is not guilty. You move to say they are guilty, and this is similar to sending an innocent person to the gas chamber. Let's just note that if the type 2 error is occurred, then that is the same thing as saying that the defendant is not guilty when in fact they are guilty, and that basically boils down to letting a guilty person go free. Now, we can all agree that committing an oops, well, that's not the best thing that could happen. But between these two oopses that could possibly be made, let's just note that the type 1 error of sending an innocent man to the gas chamber is a lot worse, at least I hope we think so, than setting a guilty man free. So, as always, I will see you in the classroom. Cue the music. I'm out of here.